Hi. Today we will continue our discussion from last week on forces and Newton's laws. We saw last week that there were all kinds of different forces. If we have a block, which I'll call A, and block A is on a table, a rough table, and there's a rope attached to it, which is pulling on it. It has a tension. We saw that there were all kinds of forces on this block A. First, there was the tension from the rope pulling the block this way, so the block will be moving to the right. Second, the table is rough, so there will be resisting from the friction of the table, so there will be a friction force in the opposite direction from the tension force in the direction of motion. Block A has a mass, so it has a gravitational force, F grav, which is equal to the mass of A times the gravitational constant of the Earth's gravitational constant. And there is a fourth force from the table. The table is resisting the downward acceleration from gravity. It's pushing back up. This is called the normal force, F normal. And we learned last week that these forces on a free body obey Newton's second law. Which says that for a free body, the sum of all the forces in each of their different directions is equal to the mass of the free body times the acceleration of the free body. And today we're going to add to Newton's second law, Newton's third law. We have a block A, and it's attached by a rope to a block B, and it's on the rope is under tension, and block A feels a tension force moving to the right from the rope, and by Newton's third law, block B will feel the same force from block A through the rope pointing in the opposite direction. So Newton's third law is the force of body A on B is equal in magnitude, but in opposite direction of the force B on A. Through the rope, body A feels a force through tension from body B, pointing towards body B. Body B feels the same tension force from body A in the opposite direction. And we're going to use Newton's second and third law together with our knowledge of forces to solve a problem. The problem we're going to look at is this one here. So, in this problem here, we have a block A, and we know for the block A, it's got the gravity force. It feels the normal force. There's a rope here. It's being pulled on by B. It feels a tension force. And finally, the table is rough, and it feels F friction. So there are four forces on A. B, the situation is simpler. it feels the gravity force, which for B is mb times the gravitational constant g. And it feels the tension force, which by Newton's third law is in the same magnitude, but A is being, A feels the force pulling it to the one way, B is now going in towards the A direction, it's going upwards here because the rope is bent. Okay, so we can now use Newton's second law to write two equations. The gravity force and the normal force on block A, the gravity force is down, the normal force is up, they cancel. So we only need to look at the tension and the friction. The mass A times its acceleration, it's accelerating in the direction of t, and the frictional force is in the opposite direction, and the other two forces cancel. For mass B actually will, because the rope is taut, will be accelerating at the same acceleration. Mass B times A, by Newton's second law, it's accelerating downwards, so it will be the gravity force mBg minus t. And so we end up with two equations. We could actually do some algebra. We could, for example, cancel the tension, which is a value that we don't know. And we can do that by adding the two equations. When you add the two equations, you get ma plus mb times a. The t's cancel. You get mbg minus F friction. And we end up that A equals mbg minus F friction divided by ma plus mb. And so this is an example of using forces together with Newton's second and third law. See you tomorrow.